Okay, so in this video, we're going to calculate something called, or at the end of the video, we're going to calculate something called the standard deviation. That's our goal. By hand first, and then once we do one or two, then we're going to switch to calculator in class because this would just take too long for everything. So the most common measure of spread. So when we did mean, median, and then IQR, those are all measures of center. So this one, we're going to calculate the measures of spread. So when we're talking about the acronym SOX, right? Centers, outliers, shape, outlier, center, spread. This would be the last one. We want to talk about the most common measure of spread. Looks at how far each observation is from the mean. Okay, that's kind of important. We want to know how much of your data, so if your mean is a 5, how much of your data goes, really far out, how much of your data goes, what's the farthest it goes out here, what's the farthest it goes here. Each point, how far is this point from the average? How far is this point from the average? How far is this point from the mean? How far is this point from the mean? Right? We want to know how far is each data point from the mean, right? And because that's important, we want to know how far. So this measure is called the standard deviation, but before we even get there, calculating it by hand is going to be a little difficult. So first thing we want to do is we want to calculate the mean, right? So here we have number of pets for, I don't know, for whatever, maybe per household. Oh, owned by a group of 9 children. I'm sorry, I didn't read the last part. This is owned by a group of 9 children. So somebody has 1 pet, somebody has, a bunch of kids have 4 pets, all the way up to somebody has 9 pets, and you got to wonder what kind of pets they have, right? So we find that the mean is 5. So we take all these observations, 1, 3, 4, 5, 6, 7, 8, and 9, and our average is not 5, or the mean is 5. And then we calculate each deviation. So it's basically the observation minus the mean. And for a deviation of 1, right? Our deviation of our data point of 1 minus 5 is going to be -4. And then you do the same thing for the next one. 3 minus 5 is going to be equal to -2. And you do the same thing for 4. 4 minus 5 is going to give you -1, right? And we have one data point at 5, so it's 5 minus 5, standard deviation of 0, and so on and so forth. So up to 8, 8 minus 5, and then 9 minus 5, and that's a deviation of 4. So you do this with all your observation points, right? And you get something that looks like this. Sorry, there you go. I'm going to hide this. I don't care if you can see it on your slide, otherwise, whatever. So, xi being your observation point. So xi minus your mean gives you these values right here. So if you sum all these up, right, I'm going to do that really quick on the calculator. Clear. We have -4 plus -2 plus -1 plus -1 plus -1, right? Because we have 3 observation points at 4, plus 5 plus 4, so that gives you plus 9. So we get 0. Okay, what's the sum equal to? 0. All right, so that should strike you as, okay, what's the point? Now, the question is, what are you going to do with that? Right? So you're going to square each deviation after you do all this. So you have, I'm going to do another column because this will make it a little easier. All right. So we have this is going to be like xi minus x bar squared, because the mean is just the same as x bar, right? So this is xi minus x bar. This is xi minus x bar squared, because it wants you to square each one, or it wants you to square each of the answers. Okay. So because that's not very helpful. 0 is like, what? What are we going to do with 0? Nothing. Can't do anything with 0. Okay, so negative 4 squared is going to give you 16. Negative 2 squared is going to give you 4. That's a 1, that's a 1, that's a 1, that's a 0, that's a 4, that's a 9, and that's a 16. Now we're getting somewhere. I'm pretty sure if I add those up, they're not going to come out to 0. Just saying. All right, 16 plus 4 plus 1, 2, 3 plus 4 plus 9 plus 16. Okay, I get 52. All right, well, what do I do with that? 52 doesn't really, that's not really telling me anything about how far all of the data points are from the mean. All right, so once you get 52, find the average square deviation. Okay, so the average square deviation is, okay, I have 52 data points, and there's an actual formula for this. Calculate the sum of the square deviations divided by n minus 1 is called the variance. So our variance is going to be 52 divided by 9 minus 1. We have 9 data points minus 1, so that's 8. So 52 divided by 8 is going to give us 6.5. Okay, but 6.5 isn't, this is just the variance, right? Now, the standard deviation. The 6.5 isn't going to help you. 6.5 is not going to be something useful because if our mean is going to be at 5, 6.5 out from that is just way too far out. It's like in 11 point something something or 11.5. The standard deviation is you take the square root of the variance. So that would be 2.55 pets. So interpretation-wise, let's see if I can help you understand what you just found. The standard, if you have the mean at 5, right, most of your data points are within 2.55 away from your mean. Hopefully that makes sense. So most of your data points are within 2.55 pets away from your mean. So this is how your book actually interprets this one too. 2.55 is the typical distance of values in the data set from the mean. In this case, the number of pets typically varies from the mean, so to the left of the mean to the right of the mean, by about 2.55 pets. All right? So, okay. Does that help? And in answer to your question, why are we dividing by 9 minus 1? We do that later when we talk about degrees of something called degrees of freedom back when we get to chapter, I think it's chapter 7 or so. That'll be explained in that area. But for now, just suffice it to say, so you take how far away each number is from the mean, and well, that's not going to help you because it's going to sum up to 1. Sum up to 0. You square that because distances are typically squared. Distances are typically positive. And that's where the problem actually comes in over here, because the distance between two numbers should always be positive. And the best way to turn that number into a positive number is to square it. Then you retain the same, the distances are the same. So then you sum all that up, right? And then you divide by how many data points you have minus 1. In this case, we had 9 data points. Subtracted by 1 is 8, and you get 6.5. That's your variance. You take the square root of that, and that's your standard deviation. All right? Now, to make it really easy, your calculator actually would do this for you. So if you have this data set up here, you can just press a couple of buttons, and it will give you the standard deviation. So the typical distance away from the varies from the mean by about 2.55 pets. All right, and we're going to calculate that. This is your formula for the standard deviation. Like I said, you actually do need to memorize this, and you need to see what it looks like, and you need to know that this is the standard deviation formula. But trying to do this all by hand every single time is not going to be what you're going to do on the AP exam. You're going to do this on the calculator and button punch. All right, so a couple of things really quickly. we have a choice between two descriptions for center and spread. So, two descriptions for center and spread: the mean and standard deviation, the median, and the interquartile range. All right, and then choosing measure of spread and center. The median and the IQ are usually better than the mean and the standard deviation for describing skewed distribution or a distribution with outliers. So remember, the median is more resistant if you have an outlier because it's not getting pulled like your median would towards your outlier numbers. The mean and the standard deviation are only for reasonably symmetric distributions that don't have outliers. So you kind of have to plot your data a little bit and then see what you want to do, because you're not going to really be able to tell right away from a bunch of numbers if it's going to have a symmetric distribution or a skewed distribution. All right. So plot your data first, and that'll tell you which one to use. Okay. And then the last, is there anything else that I have to go through? No, I think that's it. The last bit was I wanted to go over, no, I think I pretty much said it. All right, that's it. I'm going to give you a check for understanding question in class rather than on the video, because I want you to actually plot some data points on this, and it's kind of hard to do in the video. So hopefully you are ready to do your check for understanding questions in class, and I will see you guys when I see you.